type exactly what you want and get back nothing useful. That's the everyday reality of keyword search. Behind the scenes, traditional databases compare your query letter by letter against stored records. If the words don't match perfectly, the result is silence. But here's the problem. Human language is messy. We use dozens of different phrases to describe the same idea. And that gap between how we speak and how databases listen, that's exactly where AI hits a wall. Here's the real problem. Traditional keyword search needs an exact word match to find anything. So if a user searches for affordable housing, but your document says low-cost apartments, that's a complete miss. The system has no idea those mean the same thing. Now multiply that across millions of queries. Studies show keyword-based retrieval can miss up to 70% of relevant results. That's not a minor gap. That's your AI application failing most of the time without anyone realizing it. Here's the wild part. When you search Google for running shoes, it only finds pages with those exact words. But a vector database does something different. It converts every piece of data into a list of numbers, sometimes over 1,000 numbers per item. Those numbers capture meaning, not spellings. So sneakers, trainers, and Trudy athletic footwear all land in the same neighborhood. The search doesn't scan for matching letters. It calculates which points sit closest together. That tiny shift unlocks everything modern AI can do. Here's what's really happening inside that model. It reads a word and asks hundreds of questions about it. Is this thing alive? Is it abstract? Does it relate to power, to gender, to time? Each answer becomes a number, and together they form a unique fingerprint, the vector. What makes this powerful is that similar meanings land near each other in that number space. Synonyms cluster together. Antonyms sit far apart, and the relationships between words become actual math you can compute. That's why the king-queen example works. It's not a parlor trick. The model genuinely learned the structure of language by mapping meaning into geometry. Imagine searching for a book in a library with 10 million volumes. You could check every single shelf. That's called a brute force search, and it's painfully slow. Or you could use a smarter system. Think of it like an express elevator. The top floor gives you a bird's eye view, just a handful of landmarks to orient yourself. Each floor down gets more detailed, more specific. By the time you reach the ground floor, you're standing right next to the exact book you need. The key insight is what you skip. Instead of comparing your query against every single vector in the database, the algorithm eliminates entire regions it knows won't contain good matches. That's how you go from a 10 million vector haystack to your nearest neighbors in under a millisecond. Not by searching faster, but by searching less. Here's what that comparison matrix won't tell you. Managed services like Pinecone handle sharding and replication automatically, meaning your search stays fast even as you grow from 1,000 vectors to 1 billion. But that convenience comes with a monthly bill that scales with your data. Open source tools flip that equation. You own everything, but you're also the one waking up at 3 a.m. when a node goes down. And pgvector? It's the sneaky smart choice if you already run Postgres. You skip an entire infrastructure layer. No new database to secure, no new backup strategy to learn. The real question isn't which tool is best, it's which trade-off you can live with 6 months from now, when your dataset has grown 10 times larger than you planned. Here's what makes this layer so critical. When your chatbot answers a customer question, it doesn't search through documents like you'd search Google. It converts that question into a vector, then finds the closest matching vectors in your database. That lookup happens in milliseconds, even across millions of records. The same mechanic powers all 3 patterns you see here. Swap out the chatbot for a search bar or a recommendation widget. Underneath, they're all doing the same thing, measuring distance between vectors. Build this layer once, and every AI feature your team launches next plugs straight into it. One investment, compounding returns. Here's what actually changes behind the scenes. Without a vector database, your AI is basically winging it, pulling from general training data that knows nothing about your business. Add one, and every response gets anchored to your real documents, your actual knowledge base. Engineers at companies making this switch report that support tickets about wrong answers drop by over half. That's not just a better search bar. That's the difference between an AI tool people avoid and one they actually rely on every day. Here's what most people don't realize. Chroma stores everything locally. No cloud account, no API key, no billing surprises. You're running a real vector database on your own machine in the time it takes to watch this video. And once it's working, you can scale it. Swap in pgvector for production, connect it to a live RAG pipeline, or plug it into an agent that answers questions from your own data. The hardest part is starting, so start now.